There's a quiet revolution happening right now, deep inside the chips that power all of our AI, and it's all about memory. A new technology called high bandwidth flash, or HBF, is poised to solve a massive data crisis that's been holding AI back. Let's break down why this is such an absolute game changer.
So what is this crisis exactly? Well, we have these unbelievably powerful AI processors, right? GPUs that get faster and faster every single year. But there's a problem, a hidden bottleneck, a fundamental flaw in the system that's stopping them from actually reaching their full potential.
And this really shows the problem in a nutshell. On the left, that's where we are today. The GPU is a powerhouse, no doubt. But to get the data it desperately needs, it has to go through this slow, narrow little bridge called the PCIe bus. It's like trying to fill an Olympic swimming pool with a garden hose. And the result? Up to 30% of that GPU's power is just wasted. It's literally sitting there, waiting for data. Now, HBF, what you see on the right, it just demolishes that bridge and builds a direct data superhighway in its place.
Which kind of leads to this really simple but powerful question. What if the computer didn't have to make that slow, painful trip to the remote library for its data? What if you could build the entire library right next to its desk? Well, that is the core idea behind high-bandwidth flash.
And the solution, when you see it, is just beautifully elegant.
So, think of it like this. The super-fast memory that's already on the chip, that's called high-bandwidth memory, or HBM, that's your desk. It's small, but it's incredibly fast, perfect for whatever you're working on right this second. But HBF, high-bandwidth flash, that's the entire multi-story library built right next to that desk, holding a truly vast amount of information ready at a moment's notice.
Now, this is a crucial point. HBF is not here to replace that fast HBM desk. No way. It's here to complete it. It creates this whole new essential layer. It holds all the warm data, the books you're probably going to need soon, right there locally. So the processor never has to suffer that catastrophic delay of going all the way to some remote archive.
And the numbers on this chart just lay it all out perfectly. You can see exactly how HBF fills that gap. I mean, look at capacity. HBM tops out at maybe 48 gigabytes. Remote storage has terabytes, but it's slow. HBF slots right into that sweet spot, offering over a terabyte of capacity. But here's the kicker. Look at the speed. It's aiming for 80, maybe 90% of HBM's incredible bandwidth. This is truly the best of both worlds. You get massive capacity delivered at incredible speed.
So how on earth is this kind of performance even possible? Let's pop the hood and take a look at the engineering that makes HBF tick.
The construction is actually elegantly simple. It all starts with a base layer called the interposer. You can think of that as the foundation, that direct data superhighway to the GPU. Then you place the logic die on top. That's the brain of the whole operation. And finally, you stack the skyscraper, the 3D NAND stack built from hundreds and hundreds of layers of memory cells.
And the secret sauce to its speed? It's not about making individual memory cells faster. It's about massive, coordinated parallelism. The logic die acts like a master librarian. It gets a request from the GPU, and then simultaneously sends runners to fetch data from hundreds of different shelves, or, in this case, NAND subarrays, all at the exact same time. It's that collective effort, that huge bandwidth, that delivers those near HBM speeds.
Now, whenever a technology this revolutionary comes along, it naturally kicks off a high-stakes competition to control the market. So let's take a look at the key players and the strategies shaping the race to build the future of AI memory.
Okay, but first, we gotta understand the rules of this new battlefield. Forget everything you hear about the nanometer race with CPUs. That doesn't apply here. In the world of 3D memory, the competition isn't about shrinking things horizontally. It's about building higher. The winner is whoever can stack the most layers, vertically, pushing from 200 to 300 and even beyond.
And right now, two very different strategies are emerging. On one side, you've got SK Hynix, who's partnered up with SanDisk. Their whole play is about speed to market. They're creating an open standard to build an entire ecosystem, like right now. Then on the other side, you've got Samsung. They're taking a different route, betting it all on a long-term material science breakthrough called FeFET, which promises even better efficiency down the road.
But let's have a little reality check here. As cool as Samsung's FeFET technology is, it's just not ready for prime time. This technology readiness gauge shows it's still in the very early validation phase. It's a fantastic weapon for the next generation of HBF, for sure, but for this first wave of products hitting the shelves, that ecosystem-first approach has a clear, undeniable advantage.
All right, let's zoom out for the big picture.
Because this isn't just about a faster component. The arrival of HBF signals a really fundamental shift in how AI systems are going to be designed for the next decade.
This before and after shows you everything you need to know. On the left is a typical AI processor today. About 80% of its real estate is dedicated to raw computation. On the right, that's the HBF era processor, and the design is completely flipped on its head. A massive 60% of the chip is now dedicated to memory management, just routing, prefetching, and managing the flow of data. The processor's main job isn't just computing anymore, it's preventing itself from starving.
And this change is coming fast. I mean, look at the roadmap. Gen 1 products are being standardized as we speak. By 2026, HBF is going to be a must-have for any serious AI system, and we'll see even more powerful Gen 2 versions arriving before the decade is out.
So what's the ultimate takeaway here? What does this massive shift to a memory-centric world really mean for the future of artificial intelligence?
It means the whole game has changed. For the next decade of AI, leadership isn't just going to be about who has the fastest clock speed. The ultimate winner, the victor, will be the company that figures out how to best build and manage this vast, incredibly fast library of memory. The future of AI isn't just about thinking faster, it's about remembering better.